Now we move on to topic 3. No slides for topic 3. It's all going to be hands-on using Jupyter Notebook. It's on NumPy arrays and loops. So to create multi-dimensional arrays or just one-dimensional arrays, we will use NumPy. And in NumPy, there are also functions that operate on arrays, on vectors, on matrices. So NumPy, like I said at the beginning of this course, stands for Numeric Python, and we use it for scientific computing. It has some routines for manipulating large arrays, which could be multi-dimensional, and it does that very quickly, so it's fast, which is why we use it. And this is how we import NumPy. We can import NumPy with an alias. So this is the alias for NumPy. And then to use any function within NumPy, you will do np dot whatever function you want to use. So we already learned how to create lists, right? But lists are not arrays. You can't perform multiplication on an entire list. When you want to perform like element-wise multiplication on an entire vector, that means you want to do some matrix algebra. And the package for doing that is NumPy. And the data type for doing that in NumPy is arrays. So to be clear, you can't do matrix algebra on lists. You do matrix algebra on arrays. And the arrays will look like lists, but it's a different data type, which understands what a multiplication operator will mean if you want to multiply two arrays together. Good, so we'll get into it and you'll see examples of what I mean. So here we've created two lists. First list, A list, contains 1, 2, 3. Second list contains 4, 5, 6. We convert the first list into an array, a NumPy array to be precise, by using the NumPy array function. So NumPy.array, right? And then you provide the list, and it converts the data stored in A list, which is a list, to a NumPy array called A array. So A array is a vector that contains 1, 2, 3. How about B array? Same deal, right? It's a vector that contains 4, 5, 6. And you can print A and B, and they'll look just like the list they were created from. The difference is now you can perform matrix algebra calculations on A array and B array, whereas you cannot perform them on lists. Very important to see the difference. So when you use the addition operator on A array and B array, which are arrays in NumPy, right? They are NumPy arrays. What do you think will happen? NumPy understands matrix algebra, right? It stands for Numeric Python. So it understands that what you're trying to do is to add each element in the A array to each element in B array, and you will obtain a new array. So you will obtain a new array, which it prints on the fly, and the new array will contain 1 plus 4, right? This is A and B array. So 1 plus 4, which will be 5, 2 plus 5, which is 7, 3 plus 6, which is 9. So this line will print what? 5, 7, 9. How about the next line? A array times B array. They are both vectors, right? NumPy arrays. So it understands it's going to multiply each element in A and B arrays with one another. So it grabs the first element here, 1, and multiplies by 4, and that gives 4. First member in this second row will be 4. Then 2 times 5, that will be 10. And the last member will be 3 times 6, which is 18. How about this star star? It stands for power, right? You're raising A to the power of B. What is A? 1 to the power of 4. That will give you 1 as the first member here. 2 raised to the power 5 will be 32. 3 raised to the power 6 will be a big number, which you'll see. And then you can print A list plus B list. What do you think this will do? Do you think it will do element-wise addition? No. Why? A list is a list. And these element-wise calculations are done on NumPy arrays. So if you want to do element-wise calculations that you will define on these standard operators, and you want it to do the mathematical calculations, then you will use NumPy arrays. A plus B, what is it going to do to lists? Concatenation. We talked about this extensively in topic 2. So it's just going to be 1, 2, 3, 4, 5, 6. That's what you get from this last line. It concatenates B. It appends B list to the back end of A list. And so when you run all of these, you get exactly what we talked about. This will do element-wise addition, 1 plus 4, 2 plus 5, 3 plus 6. This will be 8 times B, so 1 times 4, which is 4, 2 times 5, which is 10, 3 times 6, which is 19, and this does the power, which we talked about. Whereas this will just append. Multiplication, exponentiation is not defined element-wise in lists. Good. Next is we can assign elements into a NumPy array like we did with lists. At the first item, which is at index 0, because indexing starts at 0, we can store 11, right? Before, what was there? It was 1, so it becomes 11, 2, 3. That's what the array will become when you print this. It becomes 11, 2, 3, because you've replaced what was in the first item by 11. How about array.fill? So these are functions that operate on the array type in NumPy. Fill. It does exactly what you would expect. It will fill up the entire array, which right now is 11 to 3. It will fill it up with 3. That means instead of 11 to 3, it becomes 3, 3, 3. You can also use this indexing, which we had used before on strings, on the other collection types, and then you can put a starting index on the left and an ending index on the right. So here we don't have a starting index, we don't have an ending index. What does that mean? Everything from the very beginning to the very end, set it all to 0. So this does exactly the same thing as fill, right? So if you want to fill the array with 3, like you did here, you could have just set all the items to 3, like so, right? Because this says put 3 in all of the indexing, starting from 0 to the very last. That's what you get when you don't provide values to the left and to the right of these. I hope that's clear. And when you print it right now, the first print statement will show 0, 0, 0. You put 3 to fill it up with 3s. 3, 3, 3. Good. Next, we can show the data type of the array using the .d type, right? Which stands for data type. So array.d type will return the type of data that is stored in the array. Arrays, unlike lists, have to store items of the same class. So if one item in the list is floating point precision and all the other items are integers, then it will make all the other items floating points. So your array will be an array of one data type. It's either going to be an array of all integers or an array of all floating points and so on. So you can figure out the data type by printing it out using the .d type, which is for data type of an array. You can also use the type function, which we've been using before, and that tells you it is a NumPy ND array. the data type is floating point. That's why I made this 3.0. And then that data type, we'll talk about it some more later, how we can create other data types. We can say array equals to, what do you think is going to happen at this point? Remember, Python is dynamically typed, right? Before, it's an array that contains 3.0, 3.0, 3.0. That's what this 3 dots means, right? And now you set to, you assign to the array. So it's no more an array. It just contains an integer, which is 2. And when you print it, it prints 2. And that's what you get here. And now we are creating another array called same name using the numpy array function. And then we provide the list as an argument. And what it does, it takes the list and converts it into an array. And here, because one item here, it's a floating point, the array will be a floating point. So when you print the data type, it will be floating point, which is what we got here. If they are all integers, for instance, like so, and you run this, what do you get? Array is an integer because all the members are integers. So very important to pay attention to the data types when you create your arrays. If you don't, you can also specify the data type or change the data type after the array has been created. And we'll talk about that in the next video.